Good morning, my viewers. It's your favorite tutor, the formula. So this morning we are going to be looking at a very tricky and challenging question to some students. And it's coming from exponential, or what is known as initial equation. Now, if you look through my board, you are going to discover we have an equation which is coming from a Y past exams anyway. So the question is telling us that 10 raised to the power y times, please, this dot you are seeing is called times. We call it dot product in mathematics. Times 5 raised to the power 2y minus 2 times 4 raised to the power y minus 1 is equals to 1. Now they are telling us to find y. We are looking for y. Now all we need to do is to quickly solve this equation and get the value of y, which we can simply do through applying the laws of indices. This is an initial or exponential equation. So all we need to do in this situation is this is base 10, this is base 5, this is base 4. Now we have many ways we can work through this thing, but one of the simplest way is to break down this 10. Just break down this 10 to what? To 5 and 2. Or we can break down this 4 to 2 so that we can have 5 and we can have 2 here. So that 5 times 2 now will be giving us 10. So there are many ways to work through this question. So what I'm going to do now is just that I will utilize one of the way in this exercise. Then in our next example, I am going to use another technique to resolve this question. So you see the way we go about this. Now, first of all, what I'm going to do here is I will write solution. We are going to, let's see, just ignore this ones you are seeing here. Work on this guy first of all. Now, we know that 4 can be written as 2 raised to the power 2. Just simplify this guy. So we're going to have 10 raised to the power y times 5 raised to the power 2y minus 2 times this 4 can now be written as 2 raised to the power y minus 1 is equal to 1. Now we are going to have 10 raised to the power y times 5 raised to the power 2y minus 2 times 2. Remember, according to the rules of indices, whenever a number, or rather according to the rules of mathematics, whenever a number comes outside the bracket, we can use this number to multiply everything inside the bracket. In mathematics, we call it the distributive law of mathematics. It's what we call the law of distributivity. So when we distribute 2 to y and minus 1, we are going to have something like 2y minus 2 is equal to 1. We are going to have something like this. Now, if you can observe what is happening now, you see that this 5 and this 2, although both of them are on different bases, but they have the same power. So, and we were told that if two numbers on different bases have the same power, we can multiply the two different bases together and raise that particular number we have gotten now from multiplying the two bases to what now? The same power. So, in this situation, we are going to have 10 raised to the power y times this 5, this 2. We are going to have 5 times 2, both raised to the power what now? 2y minus 2 is equals to 1. Recall that a raised to the power n times b raised to the power n can be written as a times b, both raised to the power n. So this is where I'm taking my law from. So this particular two different bases that are joined together, because they have the common power, the rule is taken from this particular man that a raised to the power n times b raised to the power n cannot be written as what now? A times b raised to the power what now? N. Now when we continue, we are going to have 10 raised to the power y times this guy will become 10 raised to the power what now? 2y minus 2 is equals to 1. We are going to have something like this. Now when we get to this particular aspect, all we need to do is to quickly clean here a bit, so that we can have a space to continue our work. Now, when we continue what we have here, you can clearly observe that this man and this man, they are already on the same base. Both of them are already on the same base. So according to the laws of indices, when two numbers of the same base are multiplying, what we simply need to do, we keep one of the base and add the rest powers together. So when we do that here, we are going to have 10 raised to the power y plus, we are going to have the power to the other expression is 2y minus 2 is equal to 1. So in this situation, we are going to have 10 raised to the power. Now let us add these two powers together according to the rule of algebra. Algebra is telling us that like terms can be added and they can also be what? Subtracted, while unlike terms cannot. So when we add y plus 2y, we are going to have 3y plus and minus is minus. We are going to have 2 is equal to 1. Now, the problem is, whenever we are solving an exponential equation, if we arrive at a given point, we must make sure that whatever base we have on the left hand side is still the same base we have on the right hand side. Now the challenge is, if you look at my left hand side, the base is 10. If you look at my right hand side, the base is 1. So it is either I convert base 10 to 1 or I convert base 1 to 10. But converting base 10 to 1 is an impossible operation. We can possibly not do that. So the only thing we are going to do is to convert this base 1 to 10. How do we do that now? Now, you can remember from indices that there is a law that tells us that anything raised to the power of 0 is always equal to what? 1. Recall, we were told that 10 raised to the power 0 is equal to 1. So if we have this at the back of our mind, then we can now quickly move from 1 to what now? 10 raised to the power 0. So I will just quickly come 10 raised to the power 3y minus 2 is 10 raised to the power of 0. Now since these two bases are the same base, all we need to do is to cancel the base and equate the power. So this and this cancels out. At the end of the day, 3y, we're going to have 3y minus 2 is equal to 0. Therefore, 3y is, if I collect like things, is 2. If 3y is 2 divided by 3, divided by 3, this into 3, we are going to discover that y is 2 over 3. That is going to be our answer. So y is going to be 2 over 3. So if you look at the options there, you are going to discover that this is among one of the options in that particular place. Okay, my viewers, this is the most you can do this morning. In our next class, we are going to be looking at other difficult equations pertaining to this exponential equation. Okay, have a nice day.